PhD scholar. Get started. An overview of the content that was covered in week 10 of this course. Okay, so this week we were focusing on traffic management, right? So traffic management, what are the different strategies, right? And what are the benefits and limitations associated with it, right? So that's the whole focus of this week. So we had 5 lectures. So the first lecture was an introduction to traffic control and systems management. Okay, so what is traffic management? So traffic management. So to put it simply, it is the efficient use of the existing resources. Efficient use of existing resources. Okay, so why do we do this? Because we have a lot of traffic congestion issues, delays, accidents. It's all these negative externalities are associated with the transportation system, and these issues or problems are growing, right? So therefore, to address this, earlier, the old approach, right? Earlier approach was what? Earlier approach was to build new infrastructure, right? So if you have excessive congestion, so what we would do, so we would build new roads, expand the roads by adding lanes, or build new interchanges, flyovers, and so on, right? So that's the old approach that we were doing, right? So when you provide more new infrastructure, you are increasing the capacity, right? So by increasing the capacity, you are serving the excess demand, thereby reducing the congestion, right? So this is how the old solutions or approaches, how they were, right? So these were physical solutions, but these there is a problem with these approaches, right? So what is that? So one is that one obvious con associated with this is that it is you need a lot of funding, right? So because transportation infrastructure, to build them at massive scales, right, it requires a lot of money, right? So and the second is space constraint. So because because of increased urbanization, right? So the amount of space that is available for transportation facilities, that is reducing, right? So the amount of space that we are able to work with keeps reducing. Therefore, we cannot keep on building more and more facilities, right? So there is a physical limitation as well that is associated with this approach. Therefore, we cannot adopt this as a primary solution anymore. So also we are having increase in technological advancements, right? So therefore we must try to make use of these, right? And also whatever infrastructure is already existing, to make use of those to the maximum extent possible, so that we are making use of optimal resources. Therefore we reduce the delays and condition and other environmental impacts as well. So that's the goal of the traffic management, right? So it is how do we apply the management principles and practices to optimize our existing infrastructure and road networks to improve the traffic flow and safety, right? So that's basically what the idea behind the traffic management is. And also we looked at several benefits that are associated by following such a principle. So what are the obvious benefits that we can think of? So one is because we are making use of the existing resources, we are not building new infrastructure necessarily. So we will be saving a lot of money, right? So we are not going to spend more, right? So we are coming up with solutions that are very cost effective. Second is improved mobility, right? So this is the problem that we are addressing, right? So we want to make travel more smoother and reliable, right? So by reducing congestion, so we will be providing improved mobility, and then we'll have improved uh, operating conditions, which means that passengers would be facing lesser delays. Drivers can drive with lesser stress, right? So the operating conditions will be improved or enhanced. And then we'll have also improved accessibility, right, as we will be seeing later. So access management is one of the strategies that is that is present in the traffic management. So by employing that, so we will be increasing or improving the access to different commercial and retail or even recreational activities that take place along our road network. And also it will also be able to provide real-time information to travelers, right? So that helps them make better travel plans, right? So that they do not faced with traffic congestion or delays. And another important benefit is that enhancement of safety, right? So this is one important benefit, right? So because or we can say as a side effect of managing this traffic, so we will be also improving the safety, and safety is one of the top priorities of our transportation system, right? So by through better accessibility and also safe mobility, we will be improving the safety for all the modes and different users of the transportation system. And also freight movement will also benefit. Freight movement will also be improved because so the productivity of the the goods traffic will also improve, also their safety will improve, and in overall we are making efficient use of whatever resources are available. So these are the benefits that are associated with going for traffic management strategies rather than building new infrastructure to address traffic problems. But as is the case with everything, there will also be some negatives that will be associated, with this. So, what are the negatives that are associated? So, one is that traffic generation. So the limitations are, so it can lead to traffic generation. So, how does it lead to traffic generation? So because we are providing improved flow conditions, so more people may desire to use the system, right? So that may lead to more people using vehicles. And also, even if more people are not using, even to relieve the existing congestion, our solutions may require that people travel using a longer route, right? So some people use a longer route, so that may increase the trip lengths, and that may increase the total emissions as well as a knock-on effect, right? So that is also possible. So that is one of the potential negatives. So other one is requirement of high technical capabilities, right? So compared to building infrastructure, so planning and effective implementation of these traffic management strategies requires good technical skills, right? So and that is in short supply, and therefore that is one of the potential limitations. And another limitation is that it requires continued monitoring and enforcement. Why? Because these strategies, these are dependent upon the existing traffic conditions, right? So when you are, implementing a strategy, so that will alter the traffic conditions, and therefore the strategy that you initially employed may not be, suitable forever, right? So you have to keep on adjusting the strategy or the technique, so that so that the solution is effective, right? So this means that you have to keep on monitoring continuously, and make sure that you are enforcing the strategy so that so that it serves the purpose, right? So this is not a one time solution. It requires continuous monitoring. And third is fourth is there can be conflict of interest among different stakeholders. So how does this come up? So for example, one of the strategies in traffic management is to enforce parking prices, right? So to reduce or discourage people from using certain traveling to certain areas, using their cars, right? So this parking prices will be employed so that people go choose other locations for doing the same activity, or come in public transport, or use a different route where parking is available, so congestion at the targeted location will be relieved, right? So this is one of the strategies, but this may have a conflict of interest with the business owners in those region. Why? Because they may see that as a drop, as a strategy that may lead to drop in their sales, right? Because people may go to other areas, so that can discourage them doing trade in the specified location, right? So those kinds of conflict of interest may also arise, right? So these are some potential limitations that could arise when we are doing this traffic management, right? So we should keep that in mind when we are coming up with the solutions. And we also looked at what are the different strategies. So there are four major categories of the traffic management strategies, so which were covered in the subsequent lectures. So one is the access management. So access management is basically how do we control the entry and exit of vehicles along the roadway, right? So that's what we call it as the access management, right? So access to and from the roadway system, right? So that is controlled so that the conflicts are reduced and safety is enhanced, and also the mobility or the flow is smooth along the roadway, right? So that's the overall goal in the access management part. Next is the demand management. So in demand management, our the strategies will try to encourage people to do mode shift from private vehicles towards public vehicles, right? So because private vehicles generally are single occupant vehicles, right? Uh, and then the public modes are shared modes like carpool, van pools. So these are non-SOV modes, right? So where multiple people share the same vehicle, so that this is better than the every person having their own vehicle, right? So here the strategies are focusing on shifting people from SOVs to non-SOVs, or right. So or even if people don't shift modes, the strategies can still nudge people to travel in out of peak hours or off peak hours, right? Which means that during the peak hours, if everyone travels using their SOVs, it can lead to congestion. But if they travel at different times, the same number of people travel at different times of the day, the demand at any one particular point will be smaller. So therefore that can also lead to congestion, relief in the congestion, right? So therefore these kind of strategies look at how do we affect the demand so that the load on the transportation systems reduces, right? So this includes alternative transport options like non-motorized modes or transit modes or ride sharing, and like carpooling or van pooling, or provide incentives for shifting or changing their travel hours, like providing flexible work schedules, or doing this parking pricing or congestion tolls, etc., and also doing different parking management strategies. And then the third set of strategies include focusing on buses, right? So these are transit or bus priority measures, right? So here the whole focus is on the transit vehicles, right? So how do we make transit service more attractive, right? So specifically we look at buses, right? So how do we improve basically the speed of these vehicles, right? And also we can look at the travel cost, right? So that these transit services are competitive to the private options, right? So this can be done. One is speed, and another one is reliability of the travel times with the transit, right? So we're providing dedicated like corridors, or like signal priority measures. So transit services will have an advantage over the personal vehicles, so that their travel times will be more will reduce and also be more consistent every time, right? So this will be an attractive feature of these transit services, so that people will actually move towards these modes, right? So this will include numerous benefits, like one is obvious reduction in the congestion and delays, and also there will be decrease in the emissions, right? So instead of everyone having their own vehicles, if people use say for example buses, so the total emissions will reduce, right? So these are some of the major advantages in these bus priority systems. And finally, we have the emerging traffic management measures. So here, basically whatever we have covered so far: access management, demand management, and bus priority. So how do we, how do we employ or implement these strategies by making use of the intelligent transportation systems? Like for example, the use of, detector loops, so we can get real time traffic flow, right? So you how do we use those data, right? So to to implement these strategies or solutions are adapted to the real-time traffic conditions, right? So that is the focus of the emerging traffic management measures. Or we can make use of providing information or warning to the travelers, so that they can plan better, right? So how do we make use of all these technologies to do the traffic management more effectively and in real time? So that's the focus of the emerging transit management issues. So so when it comes to access management in the second lecture, so we were looking at what are the different principles that are there for an effective access management. So here the major concept that we are looking at is accessibility versus mobility. So what is this? So this is basically the two major functions associated with the different roadway facilities, right? And the focus of a roadway system should be based on the primary function that it serves. For example, if you are looking at freeways, the primary function of freeway is to provide high speed mobility, right? So in that case, accessibility will be lesser, right? So we have to have very restricted access to the freeways, right? So it not you cannot enter the freeway at any point. There will be only specific designated entry and exit points through which only you can access the freeway system. So this ensures that there will be minimal delays and conflicts along the freeway, so that people can travel longer distances faster, right? So that is if you have a facility where mobility is the primary function. So on the other extreme, we have the local streets or even minor collector roads, right? So here the function of these roads is to collect the traffic from the surrounding neighborhood, right? So to provide access to the local neighborhood is the major function of these roads. So in this case, mobility is not the major focus, right? Here so the speed is not the major criteria. So here the main focus is to provide easy access to the neighboring locations. So here we focus on the accessibility part. So our management strategies should also be based on the function that the roadway provides, right? So that's one of the major principle that we have to keep in mind when we are looking at the access management. So by limiting the direct access to the major roadways, and the other one is by promoting intersection hierarchy. So basically, as we know, so that at the top level we have the freeways and expressways, then we have arterials, we'll have major and minor arterials, then we have collector roads, and then we have local roads, right? So, so when we look at how the connections between these different hierarchical roadways are there. So, local roads should be connected to collector roads. Collector roads should be connected to arterials, arterials to expressways and freeways, right? So that's how the transition should be ideally. Okay, so we should not, a collector road should not have direct access to a freeway or an arterial, right? So that is not desirable, right? So this we should make sure that the hierarchy is maintained between the different roadway systems for a smoother transition. And also the placement of signals also should be such that the through movements are favored, right? So that the delays are reduced. Also the location of the signals, right? So if you have signals that are too far away, providing coordination between them will be difficult, right? So as we saw in the previous week, when you have larger link separation between the signals, it leads to dispersion of the platoons, right? So because people will not always travel in a group, when you have larger distances, the individual vehicle speeds will vary a lot from the average platoon speed, right? So this leads to diversion, right, dispersion, and therefore that will negatively impact the signal coordination, right? And also if you keep the signals too short, that may lead to more and higher delays as well. Even if you have coordination for one direction, the delays may increase for the other direction, right? So the placement of signals become important. So ideally, the desirable distance is around half a mile, between the signals, right? So that's like a thumb rule that you can keep in mind. And so one of the major other major principle is that to reduce the conflicts, right? So by providing by separating the turning movements, or by providing channelizing islands for the the turning lanes, so we can reduce the conflicts, and this will improve the through movement flow as well, right? So these are some of the major principles that we came across in the access management. And yeah, one more thing is that concept of complete street. So what is complete street? Complete street are basically streets which are designed for all users, right? So we have like pedestrians, cyclists, young people, older people. So how do we how do we provide a street or a road system which is safe and also provides mobility for all these different users, right? So there will be different elements like having wider footpaths, cycle tracks, transit lanes, and carriageway for the cars, benches and all these things. So all these different functionalities are carefully designed so that one is it is safer for everyone, and two, the mobility needs of different user groups are taken care of, right? So that's the major aim of these complete states. So these also come under the access management. And yeah, then we moved into demand management principles, as I said earlier. So demand management is composed of strategies where which focus on shifting people from single occupant modes to non-single occupant modes, or shifting the travel hours to out off peak periods, right? So here we were looking at different strategies. So one is the use of transit, van pooling, and carpooling, right? So here we are making use of the concept that we want to transport people and not vehicles, right? So our primary goal is to move people from one location to other, right? So and the effective way of doing it is if people use share vehicles, like in buses, like say 40, 50, or 60 people travel together, right? If you compare that, if those 60 people were using individual cars, so what will happen? So it requires a lot of road space, right? And also a lot of fuel requirement, emissions, right? All these negative externalities are associated with using single occupant vehicles. So here we are trying to address that So one is to have reliable transit services, high frequency transit services, and this and the success of this will also depend on how the city is designed, right? So if we have compact communities, right, so then in that case, providing high frequency transit services will be a very a feasible solution. And so for carpooling and van pooling, so it also has to be dependent upon the employers, right? So if they encourage their employees to carpool by providing different incentives, like having parking spaces which can be used only by carpool or van pool vehicles, or by providing awards for people who are carpooling. So that will encourage people to choose these options more. And yeah, so again, another employer-based strategy would be, to have flexible working hours, right? So if people are allowed, instead of the standard 9 to 5, work hours, if people are allowed to, given the freedom to work, for flexible hours, for example, instead of 9 to 5, it could be from 10 to 6, right? So or it could be lesser, number of work days, right? So for example, instead of 5 days a week, so more hours in a day but lesser number of days in a week, so that will also reduce the number of trips that are made, right? So or like telework, right? So work from home. So these kind of strategies, these are dependent upon the employers, right? So they can also help with this traffic management, by adopting these different strategies. And then we were also looking at strategies like congestion pricing and parking management. So here, so what the idea is that, so we want to reduce the number of vehicles that are using a particular facility, or a particular, or driving to a particular location, right? So congestion pricing is basically, so during the peak hours, right? So when the congestion is higher, so the prices for using that particular facility, like the toll charges, will be higher than in the off-peak hours, right? So the idea is that, so people, if this difference between the pricing is significant, then people would if they have an option, they would choose to travel in the off-peak hours where the charges are lower. Thereby, during the peak hours, our demand will come down, right? So that's the idea. So similarly in the parking case also, right? So so in the congested, heavily congested areas, if the parking prices are higher, again people, if they have an option, they will choose to go to a different area where the same activity can be performed, or they will try to come to this location at a different time when the prices are lower, right? So that is the idea behind the congestion pricing and the parking management. Okay, then we were looking at the bus priority treatment, or bus priority measures. So here again, the focus is solely on the public transit vehicles, specifically buses. How do we improve the service, right, and make it attractive for users, right? So basically increase the speed, and also we can provide fare incentives also. So here we have two major sets of measure treatments, or solutions. One is signal based, which is like operational changes that we can make. So other is a facility based, which involves physical changes to the infrastructure, right? So these are two major categories. So under the signal based, so we had different uh, measures, so which involve passive signal priority, active signal priority, preemptive signal priority, and we have, yeah, we also have a real time priority, right? So these are different methods that are available within the signal based priority measures. So when it comes to passive priority, it is like a pre-timed signal, right? So we had a pre-time, we were looking at pre-time signal. So this passive priority is like adjusting this pre-time plans, right? So we have fixed so this does not adapt to the changing traffic conditions, right? So you predetermine the traffic plans, such that the routes where the or the approaches where the bus services use, so those get a higher, maybe higher green time, right? So so you decide that in advance, so that the delays for the buses that are arriving at the signals will be minimal, right? So there is lesser flexibility and adaptability of these passive measures, like you can implement these by using by splitting the phases, right? So instead of having a single a longer green, so you can split it into two shorter greens, so that so the bus will have a higher chance of so the bus need not wait at the red phase longer, right? So the green phase will occur frequently. So that is one way. Other way is to adjust the phases, right? So when the adjust the phases, such that the phase in which, or the approach in which the the bus comes, that gets a larger green, right? So those kind of adjustments could also be made. Uh, and then moving on to the active system. So active system is here, so we look at, so here the bus arrival is detected, right? So it is not a pre-timed or a completely fixed adjustment. So here, so we are able to detect the arrival of the bus, and only provide the priority based on the bus arrival, right? So, and also decide, if the bus has if the bus is running late, or if the bus is running on an important route, or if the bus is carrying higher passenger load, right? So depending on these measured variables, so we can provide priority to the buses on a conditional basis, right? So that is the active measure. So this is more more efficient, right? So because, yeah, we are not delaying the other vehicles unnecessarily all the time, right? So only when the bus is present, we try to provide the priority to the buses. So this is more efficient or more optimal than the passive treatment. And then we have the real-time priority. So real-time priority is basically like an extension of our active priority, right? So where in active priority we are only detecting the arrival of the buses, so whereas in real-time priority we try to look at all the vehicles together, right? So we are looking at the bus arrivals also, and so we are trying to monitor the flow of the other vehicles, right? And here what we want to do is minimize the delay for everyone in total, right? So that's the overall goal, right? It's not that we want to only reduce the delay for the passengers on the bus, right? So we want, our idea is to have reduce the system delay, right? So in real time priority, that's what we try to do. So how we look at the system as a whole. So here the system is all the vehicles that are near the intersection, right, that have approached the intersection. So how do we reduce all of their delays? So by looking at everyone in total, right? So that's the real time priority. And finally, we have preemption. So preemption is basically, so whenever a bus arrives, right? So immediately, so whichever whichever approach had a green phase at that time, so it is immediately stopped, and the green for the phase in which the approach in which the bus has come. So that for that the green is provided, right? So this is immediately, so the bus never have to stop, right? So that's the preemption, but this has negative impacts, right? So this can severely affect the um condition on the the other approaches, right? So therefore this is not commonly used, but except for emergency vehicles, right? So instead of for all the public transit, it's only for like ambulances, fire trucks, or police cars. It's where emergencies, for these emergency situations, this preemption can be adopted. So those are the different signal-based treatments, and then we have several facility-based treatment as well. So what is facility-based? This involves using changes to the roadway, right? Like providing dedicated spaces for buses. Like we have busways, right? So busways are like having where buses have the sole right of way, right? So only buses can use that particular roadway. No other vehicles can use it, right? So there is no shared space between buses and other vehicles. But again, we cannot provide such busways everywhere, right? So mostly in uninterrupted or highway facilities, buses can be provided with such busways, so that they don't have to interact with other vehicles. So more common thing to do in urban spaces would be to have exclusive bus lanes, where out of those multiple lanes that are there for the traffic to flow, one particular lane will be designated for buses alone, right? So those lanes only buses can travel. So because of this, again, the travel time for the buses will be reduced. Okay. And then we have shared bus lanes. In shared bus lanes, so again, not all the vehicles can use the shared bus lanes. So buses and high occupancy vehicle, right? So where people are carpooling, so those vehicles can also use those lanes, right? So again, there is limited interaction with other vehicles. So here again, the idea is to promote people to use high occupancy vehicles, right? So buses is also high occupancy vehicles. So buses and people carpooling or van pooling, so they can use. And some cases bicycles may also be allowed to share the these shared bus lanes, right? So these are some of the uh, bus priority treatment measures that we have looked at. And then finally, in the last lecture, we were looking at emerging traffic management measures applied to these different principles, right? So active traffic management, active demand management, and active uh, parking management, right? So here, how do we make use of the detection technologies, right? So to come up with more, so active here means we are monitoring that the field conditions in real time and then reacting to it, right? Right. So therefore, we are more effective in terms of the strategies that we are applying, and also there will be a better returns for us, right? So in terms of the benefits that we are achieving out of this, right? So uh, those are what we were looking at in week 10 lectures. Okay, now we shall move into looking at the some of the questions related to these and how to solve them. Okay, so the first question for week 10 is, we are given a statement and we have to either accept or reject the given one. The statement is traffic management solutions cost more than road expansion projects. So options are accept and reject. So so here this is the what we were looking at in the introduction, right? So road expansion projects. So this is the our old approach. So traffic management is our is our desired our new approach. So where we have all these different measure strategies that we were talking about, right? The access management, demand management, bus priority measures. So all these are the traffic management solutions. And the road expansion project, this can include expanding existing road, like building new interchanges, flyovers, etc. Building new roads. So when you look at it, so here we are now focusing on the cost component, right? So more than which is more benefit, which can be more beneficial in congestion relief. So we are not looking at that. Here we are only focusing on the cost component. So if you just look at the cost component, so obviously, this expansion projects are more costly. Why? Because this involves newer newer resources, right? So we want to acquire the land, build these new resources and then operate. So obviously the cost associated with these expansion projects are much higher, whereas in the traffic management solutions, so we are not building anything new, we are only making use of it in a more efficient manner, right? So optimal use of the existing resources, so that would cost us much lesser, right? So therefore, the given statement that the traffic management solutions cost more than the road expansion projects is incorrect. So therefore, we will reject the given statement. Okay, so the right answer is option B, reject. Okay, the second question is, which of the following statements are incorrect with respect to splitting of phases for passive bus priority measure? Okay, so the options are A, optimal cycle length remains same. B, increases the capacity of the intersection. C, reduces the total startup loss time during a cycle. And D, reduces the waiting time during the red interval. Okay, so here again, this is the third group of measures, right? So the bus priority treatment. So this comes under the signal based priority treatment. Right, so one of the strategies within the signal based priority treatment is the passive priority measures, right? So passive measure means fixed or predetermined, right? So this is not adaptable to the changes in the traffic conditions, right? So this is not detecting the bus arrival, so it's not employed only when the buses arrive, right? So this happens from one cycle to the other irrespective of the buses there or not, right? So this this predetermined strategy will happen. So one of the strategies within this is the splitting of phases, where instead of having one long green phase, uh, example, we have, let us say, green followed by red. So what we will do is split this into multiple phases, right? So we have green, and we'll have a red, and then we'll have again green, and then red, right? So instead of one long green followed by a long red, so we could split this phases such that neither the green or the red lasts for a long time, right? So that's for example, if a bus is arriving, if this first kind of phase was there, and a bus has arrived, just when the signal turned red, and again, because this is a passive measure, so we cannot adjust, because the bus has arrived in the red, so we cannot adjust the say the phase timings, depending on the bus arrival, right? So because this is fixed, the bus will have to wait for this entire red duration, right? So this will face an extremely large delay. For example, so if it arrived during the green, it was well and good, but we don't know if the bus will always arrive in the green, right? So there is also a chance that the bus can arrive in the red period, so that will lead to longer delays. Whereas if we had split the phase like this, so if the bus arrived during the green, well and good, so there is no delay. But if the bus happened to arrive during the red, so even in that case, the delay is small, right? So earlier we had a large delay. So even if the chance of arriving in the green is there, so the delay is less, smaller delay. So that is the idea behind splitting the phases, right? So it doesn't have to wait a long time if it happens to arrive in the red phase. So what does this mean? So this means that the cycle length is going to be the same, right? So we are not changing the cycle length. We are only splitting the phase into multiple phases. So the overall cycle length is not affected. So B is increases the capacity of the intersection. So this need not increase the capacity, right? So it may actually decrease the capacity, because why, when you have multiple phases, so the loss times will increase, right? So because for each phase there will be a startup loss time, and there will be a the clearance loss time, right? So when you're splitting it, so this will be increasing. So every time a green comes, the initial vehicles in the queue, so they will experience a startup loss, right? So that will actually reduce the capacity of the intersection, reduces the total startup loss time during a cycle. So again, this is incorrect. It actually increases, right? So reduces is not right. And D reduces the waiting time during the red intervals. So that is correct. So the red intervals are not large, so that the waiting time during the red intervals come down, right? So that So only the options B and C are the incorrect one, right? The question was asking which are incorrect, right? So only B and C are incorrect, right? So A and D are correct statements. Okay, then moving on to question number 3. So here we want to match the traffic management strategies given in column X, okay, with its corresponding description given in column Y. Okay, so these are the four traffic management strategies that we have looked at. So access management, then we looked at demand management, transit priority, and finally emerging traffic management measures. Okay, so we are given with four descriptions. So description A is use of intelligent systems to manage traffic flow. B is design, application, and control of entry and exit points along a roadway. C to encourage shift from SOV to non-SOV, and D is to increase the speed of the buses. Okay. So first is access management. So access management deals with controlling the entry and exit into the the roadway systems, right? So that is given an option description B, which is the design, application, or and control of the entry and exit points along the roadway. So this is the correct match. One is with matched with B. Two is emerging traffic management measures. So this involves the use of the intelligent transport systems, like the sensors, to monitor, and make use of that information to manage the traffic flow better, right? So that description is provided in A. And three, transit priority. So transit priority is focusing on buses, right? So improving the speed of buses. The different strategies are available within that, but the goal is to increase the speed of the buses, which is given in description D. And finally, demand management. So here the focus is to do mode shift, right? To encourage mode shift from which mode to which mode, from single occupant vehicle modes to non-single occupant. So SOV means single occupant vehicle, right? Which means one person is only there in the vehicle, right? The person whoever is driving, so only that person is there, right? So that is a single occupant vehicle. So we want to encourage people, instead of using their SOVs, to use a shift to non-SOV modes, like which could be carpool, vanpool, ride sharing, or um, transit options. Okay, so that is the right match. So one is matched with B, two is matched with A, three is matched with D, and four is matched with C. So that is given in option C. So right answer is option C. Okay, question number 4. Which of the following statements is incorrect with respect to the functional road hierarchy? Options are A. Mobility is a primary function of the expressways. B. Local roads serve to provide access to abutting properties. C. Collector roads operate at lower mobility compared to arterial roads. And D. Freeways have a higher accessibility as compared to arterial roads. Okay. So when it comes to this functional road hierarchy, so remember this figure. So on the y-axis, so we have the mobility. On the x-axis we have accessibility. Okay, so the functional classification would be something like this. Okay, so higher mobility is associated with which facilities? Freeway, right? So they have higher mobility but lesser accessibility. So followed by freeway we have major arterials, then minor arterials, then we have major collector, and then minor collector. Finally we have local roads. Okay, so on one extreme we have freeways which have higher mobility and lower least accessibility. On the other extreme we have local roads which have highest accessibility but the least mobility, right? So in between these two we have the arterials and collector roads, which have intermediate levels of both mobility and accessibility, right? So they are not providing very high accessibility or very high mobility, right? So these are providing intermediate functionalities between the freeways and the local roads, right? So this is the functional hierarchy that we have. Okay, so with respect to that, we will look at these options and try to find out which is incorrect. So option A says mobility is a primary function of the expressways, right? So we have not written expressways here, but expressways will also be on par with the freeways, right? So they will have higher mobility. So mobility is a primary function of the expressways. This is correct, right? So because they are coming at the top, right? So we have top left, which has highest mobility and least accessibility. So its primary function is to provide mobility. So B is local roads serve to provide access to abutting properties, which is also true. Right? So because they have highest accessibility, right? So their function, primary function is to provide access to the neighboring areas. C is collector roads operate at lower mobility compared to arterial roads, right? So which is also correct, because if you look at the hierarchy, collector roads are coming, below arterials, which means they have lower mobility than arterials, right? So because this, function, if you look at this curve, so this is monotonically decreasing, right? So which means that mobility is keep on decreasing as we go down the hierarchy. So collector comes below arterial, which means they have lower mobility but higher accessibility. So C is also correct. And D is freeways have a higher accessibility as compared to arterial roads, right? So this is incorrect. That is the opposite, right? So arterials have a higher accessibility because freeways are above in the hierarchy, right? So which means freeways have a higher mobility but lesser accessibility when you compare to arterials. So therefore, only option D is incorrect, right? So the question is asking which is incorrect. So option D is the right answer to the question. Okay, then question number 5. Again, we have a matching question. So we have to match the access management strategies given in column X with the descriptions in column Y, right? So we are now focusing only on the access management. So within access management, we have multiple strategies. So number 1 is non-traversable medians. 2, complete streets. 3, separating the conflict areas. And 4, promoting the intersection hierarchy. Right, so let's look at the easier one. So one is complete streets, right? So we looked at this particular concept before. What is a complete street? So here we want to provide mobility to all users, right, in a safe manner, right? So we want to the facilities that we provide should be for everyone, right? So we should not leave anyone out. So we have to focus on safety as well as mobility, right? So that description is given in description A. So 2 is matched with A. Yeah. Promoting intersection hierarchy. So this also we know, right? So promoting intersection hierarchy is, so in the functional classification that we saw, so we had the different, we looked at the hierarchy, right? So we had freeways and expressways. Then we had arterials, collectors, and then the local roads. So promoting intersection hierarchy means, the intersection between the different road categories should be in a smooth manner, right? For example, local roads should be connected to character roads should be connected to arterials should be connected to the freeways, right? So which means this, the intersections between the roads should be, should be taking place in a smooth manner, which means from one hierarchical level, the intersection to go to should move to another, intermediate, immediately higher or lower level, right? It should not jump levels, right? So therefore the the transition will be smoother. So that description is given in C. Appropriate transitions from one road classification to another. And then traversable median. So non-traversable median. So this, here we are trying to, these are focused on the safety aspect as well, safety and the mobility aspect together, right? So non-traversable median. So here what we want to do is want to reduce the conflicts, right? So especially this is provided for right turns, right? So where the turning movement will have a conflict with the uh, the oncoming traffic, right? So you want to reduce that. So we have the non-traversable medians. So non-traversable medians will eliminate the conflict between the right turns and the oncoming traffic. So that is given in option D. So eliminate many conflict points by limiting the number of right turns, right? So because it is non-traversable, so the right turns are restricted. And finally, we have separating the conflict areas. So separating conflict area means, so yeah, again, this is also focused on the safety aspect, where we are separating the driveways from the critical approach areas of the intersection, right? So when you have an intersection, right? So and suppose you have some facility, right? So or some approach that is coming and then joining here to this road, right? So this is your driveway. This is your driveway. Okay, this approach that is kind of coming in. So we want this driveway to be as far away as possible, right, from the intersection, right? Why? Because if it is too close, it will be there will be a lot of conflicts, with the traffic that is coming from the intersection, and that will increase the congestion and the delays, and increase the queue lengths at the intersection, right? So we want these driveways to be adequately far away, located far away from the intersection, right? So that's what we call by separating the conflict areas, right? So this driveway will conflict with the intersection, so we want to separate out, right? So there should be adequate gap between the driveways and the critical approaches of the intersection, right? So which means 1 is matched with D, 2 is matched with A, 3 matched with B, and 4 is matched with C. So which is given in option B. Okay, so therefore the right answer is option B. Okay, then question number 6. Which of the following statements is incorrect with respect to traffic control signals? The options are A. Poorly spaced and uncoordinated signals hampers the capacity of arterial routes. B. As the number of signals per mile increases, the travel time increases. C. Increasing the distance between the signals improves the traffic flow on major arterials. And D. For effective coordination, half mile or more distance between the signals is desirable. Okay, so here we are looking at the placement of the signals, right? So, so the first statement that poorly spaced and uncoordinated signals hampers the capacity of the arterial roads, so which is correct, right? So because so when you have when the signals are uncoordinated, uh, and also so when the spacing is not properly done, so it will lead to higher delays, right? So because vehicles may have to stop at multiple signals because it is not properly coordinated, so that may lead to higher higher delays, right? So therefore A is correct, right? So we want proper spacing, right? As I had told before, so that should be it should not be too far away, right? So that the coordination becomes difficult because of the plateau dispersion effect. It should not be too close also, because there will be multiple intersections, multiple signals now. So this can hamper the capacity. We are looking at capacity, right? So which is not only the through movement, the major through movement, but also we have to look at the other, the crossing of the other traffic movements, right? So they should also not face excessive delays, right? So if we have poorly spaced signals, that can lead to reduced capacity actually. So that is the correct statement. So B, as the number of signals per mile increases, the travel time increases. Right? Again, this is increasing the number of signals, which means the distance between them is coming down. So which will actually increase the travel time, right? So because the delays are increasing, so the travel time is also will also increase. C, increasing the distance between the signals improves the traffic flow on major arterials. Yes. So by increasing the distance, you can improve the flow because the vehicles have to go through lesser number of signals, right? So the delays that they will incur will come down, right? So when you have a lesser number of signals. And D is, for effective coordination, half mile or more distance between the signals is desirable. So this is the incorrect statement out of the given ones, right? So half mile or more distance is, half mile or more distance is generally desirable because, as we talked about, the flows can improve on the major arterials. But, for effective coordination, that is not suitable, right? So the key here is, for what is this half mile or more desirable, right? So here the question is whether it is suitable for an effective coordination, right? So coordination becomes difficult when you have larger distances, right? So when looking at the coordination point of view, right? So then, having smaller distances is better in that from that point of view, right? So for looking at effectiveness of the coordination alone, this half mile or more distance is not always suitable, right? So therefore D is the only incorrect option here out of the given four. So D is the right answer. Okay, then question number 7. Here we want to uh, match the emerging traffic management measures with their corresponding descriptions. Okay, so within the emerging traffic management measures, so we have the dynamically priced. So this means this is basically enhanced forms of the other measures, right? So the access management measures, the demand management measures, and the traffic, the bus priority measures, right? So these will be somewhat similar to it, but doing it in a more real time and an adaptive manner. So within that we have 1, dynamically priced parking; 2, adaptive traffic signal control; 3, dynamic wayfinding; and 4, dynamic pricing. So the different descriptions given are: A, to efficiently balance parking supply and demand; B, optimize delay, queue length, etc. at the intersection; C, utilize the toll that dynamically change in response to congestion; and D, minimizes the time spent searching for parking. Okay. So first one is dynamically priced parking. So here, so this is related to the parking prices, right? So this is related to the parking facilities. So here, so why do we want to have dynamically priced parking? So here the parking prices will change depending upon how many people are wanting to use the parking space, right? So if many people are, if there is a higher demand for a given parking space, so which means that its price will go up, right? So this is like surge pricing when you are using if you have used Ola and Uber, right? So when there is a higher number of people requesting for service, the taxi fares will go up, right? So because there are more people to serve than the number of cars that are available, right? So similar to that, so when you have limited space and the demand for that space is higher, so the prices will go up. So what this will do, this will reduce the demand, right? So when the price goes up, so demand will also start going down, right? People will try to look for alternative places to park, right? So they will move from this location, right? So that is the idea behind the dynamic replacement. We want to bring this demand and supply to a balance by changing the parking price, right? So that definition given in A, right? So to efficiently balance the parking supply and the demand, right? So we want to maintain the balance. So how do we bring that balance? By adjusting the price, right? So when the demand is high then the supply, so you increase the price, and when the demand goes down, when you have excess supply, so you can reduce the price. To adaptive traffic signal control. So again, here we are looking at signal control. So when we are talking about signals, what we want to do, So we want to reduce the delays through the intersection, right? So we want to reduce the congestion, queue lengths, etc. So this is all related to intersection. So by adaptively managing the signal, so we will be optimizing delays, queue lengths, etc. at the intersection, right? So this is related to intersection control. And three is dynamic wayfinding. So this is what? So this is again somewhat related to parking management only. So here, so when the parking prices are high, right? So we want people, we want to reduce the demand from that area, right? So we should provide people with alternative locations, right? So we want to route them to better locations. So if they are not aware of alternative locations where parking is available, so they will spend a lot of time looking for a space to park. That may eventually lead to increased congestion because people are moving slowly to find the places, right? So by dynamic wayfinding, we want to minimize their time that they spend searching for parking spaces so that they can quickly park their vehicles and not add to the congestion that is already present. So that is the idea with dynamic wayfinding. And finally, we have dynamic pricing. So this is with related to the toll prices, right? So again, during the peak hours, so the tolls will be higher, right? To encourage people to travel during the non-peak hours, right? So we want to again balance out the demand between the peak hours and the off-peak hours, and we are doing that by adjusting the toll prices, right? So utilizing the tolls that dynamically change in response to the congestion. So if the congestion is high, increase the toll price, right? So that people will use that particular road less during that period. So that will help relieve the congestion. And once the congestion is reduced, we can again reduce the price, and people can so more people can choose to use that road. Right? So which is one is matched with A, 2B, 3D, and 4C, so which is given in option B. The right answer is option B. Question number 8. Which of the following statement is incorrect with respect to employer-based TDM strategies? Okay. Uh, the options are: option A makes non-SOV options relatively cheaper. B offers higher parking rates to carpools and van pools. C provision of free subsidized transit passes. And D secure workplace parking for bikes. Right. So here bikes means it's not motorcycles, so it is actually bicycles. Right. So bikes is a term used actually for bicycles in the Western countries, so not to be confused with motorbikes. Okay. Uh, so option A makes, so here what are we looking at? TDM. TDM means traffic demand management, right? So which is strategies that encourage people to use the non single occupant vehicle options, right? So which of these options are providing incentives for people to use the non-SOV modes, and which of these are not, right? So we want to find out which of these are not encouraging them, right? So incorrect statement. So option A makes non-SOV options relatively cheaper. So when making non-SOV options relatively cheaper, so people will be more incentivized to choose those options, right? So which is what is desirable, right? So that's what we want to achieve out of these. So this option A is a correct statement. B offers higher parking rates to carpools and van pools. So what happens? So higher parking rates are there for carpools and van pools means, so people, if they are bringing if they are carpooling and coming to the office, so they will be charged higher for parking their vehicles. So what will that do? So that will encourage people to not carpool, right? So which will discourage them from carpooling and make and use their own vehicles, right? So this is this will act opposite to what we want, right? So this is not a TDM strategy. Okay, it's surely not an employer based TDM strategy, right? So this will push them towards SOVs instead of non-SOVs, so which is not what we want. So B is incorrect. C, provision of free or subsidized transit passes. So this is also a correct statement because we provide free passes or passes at subsidized rate for transit. So people will choose to use transit because their cost of travel will be smaller, than when you are using your own vehicles, right? So because you can travel at a lower fare or even free, during for the work trips. So therefore, people will choose to travel by the transit vehicles, for work, right? So C is a correct statement. And D, secure workplace parkings for bikes, right? So which means that providing dedicated parking spaces for bicycles, which means you have a higher, you have more chance of finding or almost a guaranteed place for your parking your bicycles, which means you'll be more encouraged to come in bicycles, right? So if you are in a region where you can reach your office by bicycle, you will try to use your bicycle for that, right? So because the parking headache is not there, right? So this is also a strategy that the employer can adopt, right? So out of the given four, only option B is not the right strategy. So that is the incorrect statement. So the right answer is option B. Question number 9 is, which of the following characteristic is correct with respect to flexible scheduling? So the options are: increase increase the number of weekly commute trips. B, shift work trips from non-peak hour to peak hour. C, work from home. And D, increase in the number of work days per week. Right. So here, this is also one of the employer-based strategies, which is flexible schedule, right? So flexible schedule means like people are all not always required to work between 9 to 5 from Monday to Friday, right? So that's not a fixed instead of working in that fixed schedule, so people are provided with flexible schedule. So what is the characteristic of such a scheduling, right? So that's what we are looking at. So if we have a flexible scheduling, what will happen? So increases the number of weekly commute trips. So commute trip means basically traveling, the regular travel from home to work and then work to home, right? So will that increase? No, it will not increase, right? So our idea is to reduce the number of such trips, right? So that the traffic congestion is relieved. So that increase in the number of weekly commuters, it's not a characteristic. By flexible scheduling, what we are trying to achieve is the opposite. So our solutions will try to decrease the number of weekly commute trips. B, shift the work trips from the non-peak hour to the peak hour. Again, this is opposite of what we will try to do, right? So in the flexible schedule, what we want to do is want to shift the work trips from peak hours to non-peak hours, because during the peak hour is where the congestion is high, right? So delays are higher. So we want the number of trips made during the peak hours to be reduced. But instead of if you can't completely eliminate the trip, you will try to shift it to a non-peak hour, right? That's where the flexible schedule works. Like for example, some offices may still go with 9 to 5. Other offices, or other work, can be scheduled from 10 to 6. Right? So which means that a portion of the trips that were taking place, to reach the office at 9 will now be starting later, right? So which means these are staggered or scattered throughout the day, and so therefore the congestion during the peak hours will reduce. So here the shift is from peak to non-peak, not from non-peak to peak. So B is incorrect. C, work from home. Work from home is also part of the flexible scheduling. Here we are trying to cut down the number of trips, right? By working from home, there is the need to travel to the office is eliminated, right? So because of that, so the number of trips made will reduce, right? So therefore, this is one of the characteristics that is associated with the flexible scheduling. And D, increase in the number of work days per week. Again, this is not desirable, right? Not a characteristic. So what we will try to do, one is compress the number of working days, right? So instead of 8 hours per day, we could increase the number of hours worked per day and increase the number of decrease the number of days working days per week. So instead of 5 day work week, so you can have like 4 day work week, right? So but increase the number of hours worked per day. So this means that one day people need not travel to the office, right? So the number of days will come down and the number of trips will come down. It will not increase. So the only correct option is option C, work from home. right? So this is with respect to flexible spending. So C is the right answer. Then question number 10, accept or reject. The statement is by providing more access to adjacent properties on the highway or arterials, its ability to move traffic increases, right? So again, this is the accessibility versus mobility concept, right? So what we have seen so far is higher accessibility leads to lower mobility and vice versa, right? Lower accessibility lead to can can lead to higher mobility, right? So this is the trade-off that we will be making, right? So therefore, a particular functional or a particular facility, depending on its primary function, will be designed and operated, right? So whether it is accessibility or mobility, that we have to design. So here we are talking about highways and arterials. Okay, so highways and arterials are higher up the hierarchy. Where they are, they try to provide higher mobility, right? So which means that their accessibility must be lower, right? So they should have restricted access so that we can provide safe and high speed long distance movements, right? But what the statement is saying, by providing higher more access to adjacent properties, which means higher accessibility. So more access to adjacent properties, which means higher accessibility on the highways or arterials. Its ability to move traffic increases. Ability to move traffic increases means higher mobility. But these two do not go hand in hand, right? Higher accessibility will not lead to higher mobility, right? So it is the opposite, right? So higher accessibility will means the mobility will go down instead of going up. So therefore the given statement is not correct. So we reject the statement. Okay, then question number 11. Again, accept or reject the statement. Statement is queue jump lane is signal or time-based bus priority treatment. Okay, so we have bus priority treatment. So two major um, strategies, right? Bus priority treatments. So we had signal-based and then space-based, space or facility-based. So which means signal-based ones, or these are like operational changes or operational measures, like adjusting the signal timings, right? So to give priority for buses. Space or facility based, these are physical measures that are undertaken, like providing busways or exclusive bus lanes, shared lanes, and so on. So queue jump lane is also one of the space or facility based, right? So here we are providing us a lane where the buses can use to avoid the long queues at the intersection, right? So instead of facing longer queues, so which will lead to higher delays, so this queue jump lane provides allows the buses to quickly reach the stop line so that their delays in the intersections will be reduced, right? So this means that it's not about adjusting the signal timing. It's about having this dedicated queue jump lane, right? So which means that it's a space or a physical change or a physical measure that is done, right? So it's a facility based measure, not a signal or a time based measure, right? So therefore the given statement is rejected. Okay, question number 12. So here we want to match the transit priority treatments given in column X with their description given in column Y. So we have, so these are all signal or time based measures, right? So we have passive priority, active priority, real time priority, and preemption. So the descriptions are: adjust the traffic signal after detecting the bus arrival, commonly applied for emergency vehicle, pre-timed adjustments in traffic signals, buses as well as non-priority vehicles are detected, right? So these are the descriptions. So in passive priority, which means it's a fixed predetermined. solution, right? So which does not change from cycle to cycle. So which means one is matched with C, right? So pre-timed adjustments in traffic signals. Okay, this is all fixed beforehand. Two, active priority means the priority signal priority is provided only when the bus arrives, right? So which means we detect the bus arriving at the intersection, right? So that is important for active priority. So adjust the traffic signal after detecting the bus arrival, not all the time in all the cycles. Only whenever a bus arrives, we try to adjust the signal so that the bus faces lesser delay. So relative real-time property. So in active priority, we were only detecting the bus arrival, whereas in real-time priority, we detect all the vehicles, right? So buses as well as non-priority vehicles, so that we try to optimize an objective which minimizes the system delay or total emissions from the system, right? So we try to do this by detecting both buses and other vehicles, right? So we look at the traffic in total, that is in real-time priority. And finally we have preemption. So preemption, as we discussed earlier, right? So it means to cut the green given for any phase as soon as the vehicle that we want to provide preemption arrives at the intersection and provide green for that particular approach. Okay, so but again this is not done for buses, because in that case the buses run frequently, right? So in that case, the crossing traffic, right, from the other approaches, so they will face a large delay, right? So if buses keep coming, so their green times will be cut down uh, too frequently. So this is not applied commonly for buses, but for emergency vehicles this is more common. Okay, so the right matching then is 1 matched with C, 2 matched with A, 3 matched with D, and 4 matched with B. Okay, so 1C, 2A, 3D, and 4B is given in option D. So the right answer is option D. Okay, question number 13. Here we want to look at active priority treatments. Okay, so within the signal priority, we have this passive, active, real-time preemption as we looked at before. So within active, we have different measures: one green extension, red truncation, special phase, and phase suppression. And there are 4 descriptions. When the bus needs to perform a turning maneuver, adopted where the bus reaches the intersection during the amber phase, adopted when the bus reaches the intersection approach during the red time, non-priority phases are skipped. Okay, so green extension means, so which means the bus has so green extension means you want to extend the current green time. Okay, so which means the bus is arriving just near the end of the green phase. Okay, right, so that we want to make sure that the bus can pass through, right? So without having to wait. So what we do, so when the amber phase comes and the bus has just reached during the amber phase, which means the bus cannot cross, right? Only in the amber phase, if you have entered into the intersection, you can cross, right? So safely. So that's why the amber phase is given. But if you have not entered the intersection during the amber phase, you have to wait. Okay. But what we will do, so when the bus has come during the amber phase, we will extend the green, right? So instead of turning to red, so the green time will be extended so that the bus can safely cross, right? So it doesn't have to enter into the red phase, right? It doesn't have to face the red phase. So one is matched with B. So the opposite of this is red truncation, right? So when the bus has arrived during the red period, right? So instead of at the end of the green, so it is now arrived during some red time. Since in that case, so it will have some red period remaining, right? So that it has to wait. So instead of that, we cut short the red phase and give it the green, right? So that it doesn't have to wait a long time, right? So that is the red truncation. So this is adopted and the bus reaches the intersection approach during the red time. Okay, and then the third is special phase. The special phase is the bus has arrived, so it has to make a say a right turn, right? So when the bus is not there, we may not provide this right turn phase, right? But because the bus we don't want the bus to be delayed, right? So only when the bus is present, we give this new we introduce a new phase where this turning movement for the bus is allowed, right? So that is the special phase. So this is when the bus needs to perform a turning maneuver, right? So not always. So if some buses come that has to just go through instead of turning, so this phase may not be present. But when a bus route that has to turn comes, only in that condition we provide a phase where the bus can turn. Okay, so that is the special phase. And finally, we have phase suppression where the non-priority phases are skipped. Right. So here we are going to the sequence of the phases will be adjusted. Right. So when a bus comes, some of the phases may be skipped so that the green phase for the bus approach will come quicker. Right. So this means non-priority phases are skipped. So the right matches 1B, 2C, 3A, and 4B. Okay, so that is given in option C. Therefore, the right answer is option C. Okay, question number 14. Which of the following statements are true with respect to facility-based bus priority measures? Options are A. Contraflow bus lanes are typically provided on two-way streets. Option B. Intermittent bus lane refers to a lane that can change its status from regular lane to bus lane. Option C. Exclusive bus lanes are single lane operating in one direction during one time period, then reverse to operate in the opposite direction. And option D. A shared bus lane is a lane which buses share with other special vehicles such as high occupancy vehicles, bicycles, etc. Okay. Uh, so again, these are facility-based bus priority measures, right? So here we are talking about providing, different kinds of lanes for facilitating the bus movement. So A is contraflow lane. Contraflow lane means, the movement of the bus on this particular lane will be opposite to the regular traffic movement, right? So which is in between, it is going in the opposite direction, and this is generally provided not on two-way streets but on short one-way streets. Shorter one-way streets. So bus, instead of instead of having it to go around, right, a one-way street to reach its destination, it is allowed to pass in the opposite direction of a short one-way street, right? So it is like a shortcut for the bus alone, right? And it is moving in the opposite direction. That's why it's a contraflow lane, right? So this is not done on two-way streets but on one-way streets which are of short lanes. So A is incorrect. So B is intermittent bus lanes refers to a lane that can change its status from regular bus lane to a bus lane, right? So which means that regular lane means all the vehicles can use cars, carpool trucks, buses, bicycles, so anyone can use. That's a regular lane. Okay. Bus lane means only buses can use that. So intermittent bus lane means sometimes it will be a bus lane, sometimes it will be a regular lane. For example, during the peak hours, right? So it can be a bus lane so that the bus, doesn't have to face the congestion, right? So it can travel faster. In other times, so when the demand is lower, so we can use this lane for both buses and other vehicles. So it will become a regular lane, right? So that which means intermittent lane is can change its state from regular to bus lane and vice versa. C. Exclusive bus lanes are single lane operation in one direction during one time period, then reverse to operate in the opposite direction. This is not the right definition for exclusive bus lane. This is what we call as the reversible lane. Like for example, during the morning peak hours, in this lane the will be allowed to travel maybe during towards the offices. Okay. And in the evening, most of the trips will be from the office towards the home location, right? So their direction of the bus travel will be reversed in the lane during the evening peak. Okay. So the such kind of lanes are called reversible lanes, right? It's not exclusive bus lane. Exclusive bus lane means only buses are allowed to travel on that. It doesn't talk about the directions. Okay, only a reversible lane will change its direction from one time period to the other. So C is incorrect. D is a shared bus lane, is a lane which buses share with other special vehicles such as high occupancy vehicles, bicycles, etc. So this is the right definition. So the shared bus lane, right? It's not a regular lane, right? So it doesn't share with all the all the traffic. Shared, still a bus lane, but shared bus lane, which means other high occupancy vehicles or bicycles can use the bus lane. Okay, so the right options out of these are only options B and D. And finally, question 15, which of the following statement is true with respect to adaptive ramp metering? Okay, so this is one of the the demand management strategies. Okay, A, dynamically control the rate of vehicles entering an interrupted facility. B, ramp metering signals contain red, amber, and green lights. C, allows for efficient use of existing capacity of the facility. And D, traffic signals are deployed only on the freeway. Okay, so option A, dynamically control the rate of vehicles entering an interrupted facility, right? So this is incorrect because ramp metering is to allow the control the access to uninterrupted facility, right? So because uninterrupted facilities are supposed to their primary function is higher mobility, right? So when you have vehicles accessing this uninterrupted facility, there can be higher conflicts and reduced flow because of this when they entering demand is high, right? So therefore, we try to reduce the we reduce the rate of the vehicle entry into this uninterrupted facilities, right? So that's where this adaptive ramp metering is helpful, right? So but here it says it is for interrupted facility. Therefore, this is an incorrect statement. In interrupted, we do not generally use the dynamically control the adaptive ramp metering. B, ramp metering signals contain red, amber, and green lights. So this is incorrect. So they do not contain the amber light. Only the red and the green lights are there in this ramp metering signals, right? So this is different from the regular signals. C, allows for efficient use of existing capacity of the facility. True, right? So because we want to increase, use the existing capacity to the maximum extent possible, right? So for example, in the uninterrupted facility, by controlling the entry into that facility, so the through movements are able to use the existing capacity, at a higher level, right? So therefore, efficient use of the existing capacity is is achieved. And D, traffic signals are deployed only on the freeway, right? Again, this is not true. It's not only on the freeway, on the ramps, right? Is where the signals are provided, right? So that the vehicles, on the ramp, so they are controlled, right? So it's not the control along the freeway. Okay, it's the entry into the freeway that is controlled, right? So signals are not deployed only on the freeways, right? So therefore, the only right option of the four is option C. Okay, so with that, we are coming to the end of week 10 today's session. Okay, so we'll continue with our sessions again from next week. Okay, so we'll wrap up today's session. Thank you for attending.